Hello class. In this video, we're going to talk about how to generate random variable in Excel. This is the commonly used distribution as we discussed in the class. In in the group of continuous distribution, we have uniform, then we have normal distribution, which are very widely used in practice. Then we also have discrete distribution Boolean, which is whether you do an event, whether it succeed or not, and discrete uniform, discrete customer. And I will really go through those slides really quickly so we can get a sense of what this distribution will be. This is uniform from A to B is equal likely to be taking any value between A and B. And then normal distribution is this classical bell shape. It has a very good property that most of the probability density would within the 6 sigma interval. For Boolean, they have only two outcomes, what either to be 0 or 1. 0 usually represent event happen, and 1 usually represent the event happen, and 0 represent the event didn't happen. And the length of this bar represent the chance that they would happen. And the discrete uniform is the classical dice game. If you roll dice, they're equal likely to be any value from 1 to 6. And the discrete customer is that they can take any discrete integer value, but the chance that taking this number is different instead of uniform. So in Excel, let's go to our Excel shell and then study how to generate this random variable. The first thing we need to do is to fill in this column the number of iteration. We can do by go to home, fill series with fill the number in the column, step value of 1. Say we're going to generate 500 and random variable. Now we generate a series of 500. Then we're going to do a uniform distribution. The function we use is rand in Excel, and you remember this is the function that used in Excel to generate a random variable between 0 and 1, uniform distributed, and this is the basic for our random variable generators. Okay, if you double click this, you see this. So as you see here, every time I hit enter, make some change to the Excel sheet. For example, I add a value in this cell and I hit enter, they will recalculate this formula, basically regenerate a series of random variable. This is because in let me see, in a formula here, under formula there is a calculation option, and now it's automate, which means whenever you update the worksheet, then they will update all the formula for you. If you change it to menu, say if you change to menu, now you make a change to this worksheet, type something in, it doesn't recalculate everything. Now most of the time we choose automate. Okay. And if you hit F9, it will also update the worksheet for you. F9. Yeah. Okay. Our second task is to generate a uniform distribution that is distribute from 50 to 150. So similarly, we're going to insert a series here. Stop value, step value 1, stop 500 in a column. And if you remember in the class, the formula for generate a uniform from A to B is basically B minus A. Now give you the range of this random variable. In this case is 100, the range. And then we multiply by random, which will give you a random distribution between 0 and 1. Then this together would have a random variable from 0 to 100. And then shift by 50, and we get a random variable from 50 to 150. Okay, it's the formula. So in here we're going just to use this B minus A. Oh, you see, I have already named this cell to B and A. So you should do that on your own worksheet. Plus a, which is this 50, and then we click this. Now we get a series of random variable follow a uniform distribution from 50 to 100. In next worksheet, we're going to generate the random variable for the normal distribution. And if you remember, the formula is just use the normal inverse and the probability, the mean, and the standard deviation. This is the formula, and let's implement that. Okay, go to fill. First, we're going to generate a series of number. We're going to generate 500 random variable, so we go from 1 to 500. So we just separate a normal distributed function just to use the inverse of the CDF. So the inverse of normal CDF is normal inverse. And here you're going to type the probability, that's the y. If you remember in the graph, this is the y, and then we inverse this CDF, get the corresponding x. So then we type in the mean and the standard deviation. We can have to log these cells because we have to drag this formula. Okay. Now we get this normal distributed function. If you want to do, say, change this to an integer, then you can use a round and keep this decimal to be 0. Then you get an integer. And next, in our next worksheet, we're going to generate ballooning, which represent whether event occur or not. So this is a distribution. With probability of 0.3, it will not happen. 0 with probability of 0.7, it will happen. So we are going to generate this random variable for this distribution. First step is to generate a series of value with step of 1. We put in the column, and then the random variable is just the idea is just to generate a uniform distribution function, and then if it's less than 0.3, then we'll give a value of 0. Otherwise, we'll give a value of 1. In this case, you will follow this distribution. And then we double click, and then we can calculate the mean of this. Control Shift downwards arrow, you can choose the entire row and get this. So it's very close to the actual mean of this random variable. Okay. For the next one, we're going to generate discrete uniform, and this one is relatively easy. But we're going to first generate a series from 1 to 500, and the function we use is random between. Say we're going to generate from the top, the bottom is 1. We can generate random variable distributed from 1 to 6, any number equally likely to occur from this random variable. So it can be 1 to 6, and they are equally likely. The function used is random between. So this is the random variable. You can do a bar chart to see, not a bar chart, or you can do a frequency chart to see if this is whether this discrete uniform or not. The next one is the discrete customer, and this one probably is the most complicated one we would use in Excel. So this is a distribution, right? It has value, taking the 5 value with this probability. So with chance of 0.1, x will be 36, with chance of 5%, you take a value of 44. So how are we going to do that? Let's first look at our oh, it's not here. Look at the second lecture. I believe this is where I put the so this is the idea of generating random variable, right? So this is a distribution with with the chance of 0.3, it has the value 100, whereas the probability of 0.2, they have value of 150. So the way you're going to generate a random variable following this distribution is that you first generate a uniform distribute random variable from 0 to 1. If it's in this range 0.3, then it corresponds to the value 100. If it's in this range 0.3 to 0.5, which is 0.5 is the sum of these two, is the cumulative probability. So the length of this is 0.2, and the corresponding value to this length is to this interval is 150. So on so forth in this range, the 0.8 is the cumulative of probability of these three, and the length of this is 0.3, which corresponding to this. So if the random variable fall into this range, then the value will be 200. That's the idea. So we're going to generate the random variable for this discrete distribution. The distribution looks different, but the idea is the same. So let's first build our ABC our VLOOKUP table. So this is the probability, and this is the cumulative probability. Copy as a value, so I don't want this to be to change. So the first one, the corresponding interval is just from 0.1 from 0 to 0.1. This if you see, this is just the cumulative probability, right? So the next one is from 0.1 to 0.44. So 0.44 is the sum of these two. That's the idea of cumulative, right? It's the sum of all the value before this value. So that's the cumulative. So the next one is 0.44 to 0.75. 0.75 to 0.95, and then next one is 0.95 to 1. You don't actually need this column if you are very familiar with this. I do this just to illustrate the purpose of constructing the VLOOKUP table. So in this VLOOKUP table, the first column is where you going to first column is the column where you put your lookup value. So here is 0. You're going to put the first value in this range, because that's how the VLOOKUP function would work, if you remember. Right. So this is our VLOOKUP table. I can give them a grid. Okay, and then now we have this VLOOKUP table. The next step is to generate the random variable. So first, generate a series from 1 to 500, and then we can do directly generate random variable VLOOKUP random. So this is the value we're going to look up. Let me first take in two steps. So we first generate a random variable between 0 and 1. This is the random variable we generate. It's just like in this size, this will be the random variable from 0 to 1. So the next step is we're going to tell which interval it belongs to. So we're going to use the VLOOKUP function to check which interval this random variable would belong to. The table we're going to look up is this. And we're going to return the second column because that's the where x it is, and it is a Poisson match, so we're going to use parameter true. And then we double click, then we get this. So this is how you generate a discrete customer distribution function, and you can um, you can integrate this two step into one step just by changing this to random. Then you don't need to do this again. Remember, so you see here, the value may be different because whenever they run a random, they generate a random numbers. So that might be different in this two cell.